Hello everyone, welcome back. In this video, we are going to learn detection and tracking using OpenCV. Let's get started. This is the edge detection. It's one of the operations we're going to learn today. And I'm starting with it because it looks somehow funny. But it's more than funny because this method, as you'll see, is used to detect a lot of things, especially when you want to locate or find the object on the image, and those objects can be found, identified by their age, like a number plate. A number plate has edges. It's not for nothing that plates have edges. Yeah, so let's get started. Let me close this to start from the beginning. I think you are used to the method. I mean my method of teaching. I have created a folder or a directory in which I uploaded some files and I create some code. So I'll be opening code and talking about it. And today we have 10 Python code to talk about. And the first code is about edge detection. We'll detect edge of an image saved in this directory. Actually, that's lena.jpg. And then we'll perform edge detection live, as I introduced you. With the edge detection, it will be the same method. Okay, and then we'll talk about shape detection, like circle, like a square, polygon, triangle. Then we'll also talk about number plate detection, because it has a shape in number plate. It's rectangular, so no, mostly I've seen some number plate that are suspiciously square, but mostly they are rectangle. And of course, since we have talked about number detection, we'll also talk about extracting that number, and that way involves prematurely the use of tesseract, but that's okay, even though we'll come back to text extraction a little bit later, but we'll do it only for the plate number. That's okay. And we'll also detect the colors, and then we'll learn to detect faces. We detect emotion, and we'll use a camera as a motion sensor, and we'll also try to detect emotion direction. Then we'll end up with object tracking. Okay, so without further ado, let's get started. Let's start by the first code. The style is first looking at the code and talking about it, and then running the code. So let's open it using code 011. So here is the code. The method used here is kernel. Kernel is the method used to detect edges. It accepts 3 parameters or arguments. And the first parameter is the image as loaded in the memory, in the RAM. And then there are 2 other parameters. That's threshold 1 and threshold 2. Threshold 1 is actually it's the maximum value of the pixel change, because when you detect edges, you calculate the change in the pixel. Like, the edge is a change from exposure to non-exposure. Like the exposure I'm talking about, it's light exposure. So it's like you coming from the dark to the area where the light is exposed. So the threshold 1 is that minimum value of the gradient that the pixel change, and then 200 is the maximum one. So in this case, it means between 100 and 200, if you find any change, any pixel change between 100 and 200, we know this is the edge. But this is insufficient in itself if it's not connected to the range from 200 to 255, of course, which is the maximum. It means if you find a change between 100 and 200, you will ignore it unless it's connected to the change between 200 and 255. What does this mean? It means we have 2 ranges. We have range B from 200 to 255 and range A from 100 to 200. And in the range A, changes will be constantly potential, but they will be weaker. Even though they are potential, they will be weaker if they are not connected to edges in range B. If there is no connection, if the line doesn't continue until the full or full conformed edge, which is in the range B, and this is the edge, whatever we have as the value between 200 and 255. This is the confirmed edge, and this edge, if it's connected to some edge whose gradient is between 100 and 200, this edge will be shown too, but if they are not connected, this won't be shown. This is what Kani does, and Kani calculates, and Kani will take what it considers as edge and mark it as white, and then it will take what it considers as non-edge and mark it with black, thus creating a binary image. Okay, so let's run the code. When you run the code, actually let's call it Lina. So this is it. This is Lina, and we can also change it back to I have car 1. The edge of this car, this is the edge detection of the back of my car, and this is the front of the car. And this is the edge detection of the car, my car front. Okay, let's now detect edge live. The same operation I ran in the beginning as introduction. It's saying that, let's look at the code. There's one change you need to spot. Code 01 underscore 2. Okay. Everything remains the same, but because this is the first time to learn a video capture, I think so, if I'm not wrong. We instead of loading the image in the memory, we load the camera in the memory. And this index, it means if you have two cameras, the first camera will be 0, most probably the webcam, and if you have another camera connected, it can be 1. If you have more, 2, as many as you have. But this is the default, the primary camera. You load it, and it will be capturing frames, frame after frame. And if the frame is returned, if this is Boolean, if it returns 1, it means there's something captured. Otherwise, you will issue an error that you are unable to capture anything. And if you capture a frame, then you will gray it, and now you got the image like any other image to use, and you convert to gray. This is convert color of that frame, that image actually to gray. But with the video, we are in while true because the frames will be captured continuously. That's why we are in while true. So this is one frame, but it will be frame after frame as the video is made up of a lot of frames that are sequential. Then you continue with Kenny, much like we did for Luna, the JPG. Okay, so now I think the code is understood. Now we can run the code. Oh, this is it. Okay. So, what else? Let's talk about now shape detection. Let's first look at the code. 0, 2, 1. This is the code. We have shapes.png. I have created some shapes. It's here. This shape.png is made up of a square, a line, a circle, and triangle, and we're going to see if you can identify these shapes using this code. The code used NumPy. NumPy is not new. We introduced it in the previous video, and yeah. And why do you need NumPy? NumPy is the best fit for making any calculation. It's NumPython to make a calculation, and to hold image pixels. Yeah, that's why we need it here when it comes to make any calculation and to hold numbers, like picture is made up of numbers. So we'll need NumPy. We don't want to talk a lot about this code because we took a lot of time to discuss about the code. You can watch the previous video about the OpenCV. So we discussed about what the code does, how CV2 does what it does. So I want to take a lot of time. You have this code at my GitHub account. You can go there and check. I make sure I comment every code block. So you are good. Let's run the code. Okay, I see that. Oh, I have detected a triangle. Title triangle, square. Let's see. It detected the square. This is square. Yeah, don't ignore this shape around the perimeter of the image, and I mean the border of the image. This is the line, this is the circle, and this is triangle. Okay, it's detected. That's it. Okay, and let's try to detect image in to detect a shape image like car one. You remember it's the back, the rear of my car, rear part of my car. Okay, it's run. Okay. It didn't detect any share. What's wrong? Yeah, because it's not PNG. It's JPG. Okay, here it is. I try to detect the edges, I mean the shapes on my car, and this is what I get. A lot of shapes, squares, polygon, and square, polygon, whatever, a circle, polygon. It finds a lot of shapes that you can't even think they are. Okay. That's it. Where are we now? Yeah. Let's now, since we are in shape detection, let's try to detect a number plate. Let's look at the code. Yeah, we're still using the CV2 and NumPy. NumPy is not even used, so I will remove it. We don't use NumPy here, even though I imported it thinking I could use it. I didn't. I ended up not using it. Yeah. So okay, we have that car, the wheel, analyze the back part, the rear part of my car, and we'll see if you can detect the number plate. Let's see if you can. Yeah, the new method is Gaussian blur. Gaussian blur is to blur. We're still using Kernel to detect the edges of the number plate. And there is another method, find contours. Find the contours is to find the not only the edges, but the real contours, like in the shape. As you remember, I didn't talk about it, but in the shape we had to use to find the contours, and also a threshold, like where is the limit between this area and that area. Maybe I should have talked about it earlier, but this is it. And yeah, pretty read. There's also arc length, self-explanatory, and approximate pole DP. Yeah. Okay. Please take your time and go through the code. It's self-explanatory. Okay, so it's the same method. We're trying to identify the shape, a big rectangle on the car. and that will be the numpad. Let's run this code. Yeah, I found that it's license plate. It's the only one large rectangle here, and it's gonna be a license plate. Actually, I told it in the code. Please go read the code carefully. In the code, it says if you detect if you detect image, which is a rectangle, yeah, just know after detecting edges, after finding contours, after blurring every part, if you come up with a large rectangle on the image, please know this is numpad. This is the trick to know we have numpad because we don't have so many rectangles on the rear car, rear part of the car and front part of the car. That's the trick. Okay, so you got it right. So now that we can detect the rectangle, the methodology is we detected the rectangle on the car. Why can't we extract the text that we find in that rectangle? That's where we came up with the code 04. Code 04. Here is the code. This is the front part of the car. CV2 is not new. NumPy is not new. And RE is not new. Or are we using RE? Because this is for the system, the normal library for the system. It's not particular to OpenCV. RE, let's see where I used RE. Yes, RE for matching, RE for regex. Okay, so we used PyTesseract or Tesseract for text extraction. Please take your time and go through the code. I made sure I comment every part, so it's self-explanatory, and if you happen to not understand anything, you can just write it in the comment and I'll answer right there immediately. Okay, so let's try to extract the text. To extract the text, we're using PyTesseract. Here, after finding the contour, detecting, find out this is the numpad, then we'll go down and use Tesseract to extract the text or from the filtered licensed plate or license plate. Okay, let's run the code. Yeah, this is what it detected. Yeah. Great. Detected. Okay. As you can see, we didn't use any AI so far. We didn't use YOLO. We didn't use an AI model. Yeah. It's down to OpenCV and now PyTesseract. Okay. The next code. Let's talk about let's detect colors. We'll first look at the code. This is the code to detect colors. NumPy is here because it has to store a large chunk of math and do us some calculations. Okay, so we identified the colors and we'll check live and we'll see if we can identify the color. Okay, let's try to detect the colors. I don't know how precise it is because it's in the night and I don't trust the type of light I'm using. It's saying this is blue. No, this is blue normally. Let's see. Yeah, it finds out it's blue. I'm lucky. I have these scissors. Yeah, it finds it red and it's not getting yellow, right? I have this kind of, it's normally orange. Let me change now. Can you find it? Fine, it's orange. Can you get orange? It's not knowing it's orange. That's okay, you can adjust as you want. But this is kind of it's blue. Yeah. My pen, can I find? My pen's blue normally. Yeah, blue. This is blue. Okay, this Coca-Cola bottle, red. Okay, so you can play with it and make adjustment, but mostly it will work. Okay. Then let's detect faces. Let's detect faces. This is the code to detect the faces. It's using CV2, but we using a hard cascade frontal face. Hard cascade frontal face is the library that I downloaded for you. Let me show you this library. It's called HAR Cascade, and when it comes to face detection using OpenCV, you refer to this library. It was written to detect faces using OpenCV. Let me show you its content. It's here. Loading. Might take a while. Might take a while because this is a large library. If it can't load, let's see if I can get it. I can't get it using cat. No such file, but it's here. Oh, okay. This is its name. Yes. A lot. Okay, so I just want you to see that this library is large, as large as having thousands of lines. Yes, you heard me right. It has thousands of lines. The 3,314 lines. Okay, so with this, it can detect a face, sometimes terribly, but most of the time still go correct. It will be correct. Okay, so let's try to detect the face. I'll detect the face. Before I detect the face, did I show you that I have an image face image? I have some faces, an image with the faces. This one, I asked the AI to create some faces. So we'll see if you can detect those faces. Okay. Yeah, we've detected faces. Some are not detected. This detected twice. Don't ask me why. Okay, so it can detect faces. Okay, later you can see if you can detect your face. You know how? Yeah. So yeah. Then can we detect emotion? Let's see if you can detect emotion. Look at the code. Yeah, you heard me right. We can detect the motion only using CV2 and NumPy. NumPy is here for calculation, storing some matrix. Yeah, something like that. So you don't have any special tool. You have CV2. It's computer vision. It means a computer can see and detect that something is moving. Let's immediately run the code, because if you want to know more about the code, you can read it yourself. You have the basic concept how CV2 works. So we want to be going through every code. I just make sure I comment every line, bottom line, and if you happen to not understand anything after trying, you can ask me. You can reach out in the comment section and I will answer right back. Okay, let's try to take the motion. It will be live, as you can see. This is the capture, our capture frames live. So I have two windows. Okay. I'll try to calm myself to be motionless. And a single motion. Then motionless again. Motion. So it can detect if something is moving. So this is motion, but motion now. Motion. Small motion. Okay. Interesting, right? Okay. Then I try to use the camera as motion sensor, because as you saw it, I can detect motion. So I try to use a camera as a motion sensor. So let's see what we get here. I won't even show you the code. Because the code is similar, I just added some elements. Code 08 and 09, they are all talking about the motion. So let me run the code 08. What did I add? I added this element, like at which rate is moving at. So why did I add this rate? Because looking at these numbers, you can see if you can ignore, you can adjust. For example, I told you I won't go in the code, but I now need to go in the code, because you can ignore some, you can set the level of detection if you want. So for example, I I am detecting the motion. I am detecting the motion at the percentage. Let's see if I make it, for example, 30. You'll see that I can move without being detected. I set it to 30, so small motion. You see, I'm moving but not being detected. I'm being detected when the rate is above 30. So I can ignore small motion. This is still small, but when I move like fast, like moving your hand is nothing. But it becomes a big deal when a larger part is moving, like me and my hands. Okay, you got it, right? And not only, I added a feature to save the pictures whenever a motion is detected. In the code, you will see it. You save the pictures somewhere. Okay, and it will try to show the part that was moving. You will work on this to see how precise it is. Trying to say, this part was found moving. Yeah, it's like the entire person was moving. And yeah, when emotion is detected, image is saved in the folder. This is what I decided. In the folder called motion images, and with the motion and the timestamp. Yep. This is the code. It's self-explanatory. The output folder is motion images. Okay, CV2 numpy time for timestamp, because images need to be identified or distinct by the timestamp they were taken. And then the OS to perform operation like creating a folder file. Yeah. Okay. We have advanced. And now, can we detect a motion direction? Let's see. I tried to add the feature. The code 09 similar code, CV2 numpy time OS similar, but I tried to add the feature of checking the direction. Checking the direction. I add a feature of detecting the dominant direction. Let's see. This is the motion detection, and I will try to move like this. I'm not sure how precise this is. So honestly, I didn't believe it was telling me the truth about where I was going. Sometimes it said up when I believed I was moving left up. Well, so I leave you this to manipulate it and to see how correct it can be. But in the remedy of this inaccuracy, I came up with another method of detecting the direction, that's object tracking. And that's the last operation today. The last operation will be object tracking. Yeah. Okay, first look at the code. This is a little bit special. Of course, you need to use CV2 and time for timestamp. That's okay. And math. Now it comes to calculating using math. Math is also another powerful library beside NumPy. Okay, so I call it special because you need to make sure you have installed OpenCV Contrib, and this is the library called OpenCV Contrib for Python. Remember, you have OpenCV Python. This is the library you have been running, but we didn't talk about the contribution. It means beside the OpenCV library, there's been another contribution, and this has been a separate library, and you need it all together with OpenCV. So you need it, and you need this version. It's mandatory because this feature is not in the newer or in the old contribution. You need to make sure you have it this newer. Okay, let's try to run the code. So it has this method. This method is this newer, this OpenCV contrib tracker CSRT. Okay, this is the object tracking. The code is not even load. You can read the code. Let's run the code. It tells you you're going to select. You are going to select ROI. ROI means region of interest. Then you select. Then after selecting, you hit space or enter to start tracking. Okay, I'm here. I am going to select the region I want to track. I selected my face. I hit space. Then I started tracking. wherever I am going, the object I said is being tracked. And I can say I'm going up and down. This is the precise now, you can see. I can say I'm going right, left. This is precise now. Okay. This is it. Before we end this lesson, we have an assignment. Let's look at the assignment. It's a 2-week assignment. You're assigned a 2-week project in which you will design and implement a motion tracking system where a camera rotates to follow a moving object in real time. You will build on the concept we've learned, like motion detection, object tracking, and directional analysis, and you will integrate software with hardware to control a servo motor connected to your PC, to the microcontroller, and the microcontroller is connected to your PC. This is not new, right? You remember it when we were trying to use the YOLO model to control the microcontroller. So the system should dynamically detect the direction of motion, calculate positional offsets relative to the camera's center, and send commands to the microcontroller to adjust the camera's pan and tilt angles. Your solution should ensure smooth and precise tracking of the object, keeping it centered in the frame. It means wherever I'm going, the camera is trying to follow me. This is the assignment. The assignment is to track the object and make sure you follow that object wherever it's going. Additionally, you're encouraged to enhance your project with features like saving the tracked object's path, where it's going, saving the path, logging its motion data, or integrating IoT elements for remote monitoring. If you want to monitor the object remotely, you can integrate it with IoT. Of course, this project will challenge you to combine computer vision, real-time processing, hardware control to create functional prototype. Yeah, and this is the prototype used in robotics. This is sort of project used in the pro robotics, surveillance, and automation systems. Okay, this is the assignment, and it's for 2 weeks from now. So, dear friends, I hope you enjoyed the video. Keep busy with the assignment, and yeah, learn more. If you have any question, anything to ask, you can reach out. Before I close, I have to remind you, you have this repository, and today I added a new folder, intermediate operations. That's where you will find everything we've learned today. Okay, see you in the next video. Bye.